Hi, Mr. Minnick here, helping students a little bit with this particular worksheet. That's an ACSL Boolean Algebra worksheet. Worksheet number 2 on Boolean Algebra. Okay, let's check it out. Here we have an expression that has some negation bars in it. So in this case, because the negation bar covers this operation plus, we need to use De Morgan's law to break it up. Similarly, we need to break this up. So I'm going to rewrite this carefully, keeping this term the same, a plus not b, keeping the parentheses around it. But then this term, all in a big fat set of parentheses here, the long bar gets split up into two little bars according to De Morgan's law that you should be very familiar with. And the operation that was in between those two operands, multiplication you see, now switches to plus, and we're left with the arguments or the operands a and b there, but with a plus in between instead of the multiplication. Now we did break up that long bar into two little bars, and that was a necessary step. And now we treat this part of the expression. It has this long bar that, according to order of operations, must be broken up. So in its own like big fat set of parentheses here, I'm going to break that bar up into two bars, change the plus to its sort of Boolean opposite, which is multiplication. For now, I'm going to put a dot there just to make sure I remember it's multiplication. And this A with a little mini naught is still there. The little mini naught is still there, and that B is there. So really, we don't need the multiplication operator there. You'll know that just putting them next to each other means multiplication. Okay, that's the first step. Now you can continue to break this down into equivalent steps. For example, these two negation bars cancel each other out according to, if you study the materials that we have, there's an identity that that anytime you have an operand like A or B or anything with two negative symbols, in other words, they cancel out, and you're left with just the expression A. So you must be familiar with these Boolean algebra identities and just know them. Be able to think them out. You might not memorize them, but by doing enough of these problems, you will absorb them and sort of just know them as well as you know normal math, like the distributive property, the associative property, and all that. Okay, I'm not going to do the rest of exercise 1 for you, but it does simplify to something relatively short. Number 2, that does not look tricky at all. You will be using distribution, I guess you call it. That not A will be multiplied with the B, but it will also distribute over here and be multiplied against that not C. The plus in this case stays the same. This is not De Morgan's law. This is just straightforward. Right here, the distributive property in this identity number 3. Back over here to the worksheet, so you can do the rest of that problem. It's just a lot of distribution, and it comes out to a relatively simple answer. Oh, you're supposed to change this so that instead of pluses, it's all ands. In other words, it's all multiplication. And you're still allowed to have some knots in your answer. So good luck with that, getting it to the final desired form of the expression. Number 3, the only hard part there is you're supposed to sort of change this to, you are recommended to change this to the normal notation. So not A is really A with a bar. And the C with a and C, that's really multiplying by C. Or is a plus. Now keep track of the order of operations and make sure you're using parentheses where you need to. And that not means that you end up at some point with an A plus C, because that or is a plus. That not, because it applies to that whole set of parentheses, is written as a long bar that's over the whole A plus C. And so in a way, that set of parentheses there is still sort of around that. The bar acts as parentheses, but you could also, I guess, put parentheses around it. Now I skipped something here, and you have more work to do. I'm not doing exercise 3 for you. Wow, number 4, one giant long bar across the whole thing. So your very first application of De Morgan's law to break that long bar up is you break it up into 2 smaller bars, and that plus changes to a multiplication. And everything that was under that half should just be rewritten. I'm not going to take the time to rewrite it with my special pen here. But think of all that as like x, and think of all this as y. And now you could, if you wanted to, do a little side problem and simplify this, and put it back together again. That may work. In my case, I just keep using the identities, and I just break it down into, you might need more space than I'm giving here on this worksheet. Good luck simplifying that to the simplest answer possible. And number 5, wow, that's easy. There's no De Morgan's law right from the beginning because there's no negation bars. It's just a bunch of distributivity and probably associativity and other things like a b times a b simplifies to just plain old b. Things like that. Common sense, when you're using ones and zeros, trues and falses, anything multiplied with itself, where is it? Somewhere in here, a times a simplifies to just plain old a right here. A times a is a. So that's sort of how I know that b times b at some step is really just b. Okay, good luck with that one also, and have a great day.